Today we are going to look at calculus, specifically some of the questions that were sent in by the learners. Now, these questions are lovely, i.e. I love them. You guys are maybe not going to like them, but we're going to look at them in any case. So my first shout out goes to Nkosi Professor. I love your name and I am looking forward to answering this question. So the first question, ladies and gents, asks, determine the points on the curve y equal to 4 over x where the gradient of the tangent to the curve is -1. So when we have a look at this, I always love to, first of all, before I do anything, actually get to the real thing behind what we are looking at. So I want to get to what are they actually asking me. They're asking me for points or coordinates. In other words, I know that I'm going to have to answer them with an x comma y or maybe more than one at the end. Points on the curve, y equal to 4 over x. Just hit the pause button. If you look carefully, that is actually a hyperbola. I'm saying that because it's good for you to also just think before you do something. For those of you that want to attempt this question first, hit the pause button on your YouTube channel and just wait, try it yourself, and then you can always catch up later. So they are telling me that the gradient of the graph or the gradient of the tangent is a specific value. So when I hear gradient, I think of derivatives. So when I look at gradients and I think of derivatives or dy over dx, that means for my curve y equal to 4 over x, I've got to derive that function. But before I can actually derive it, I need to handle that over x. So I'm going to take it to the top and make it 4x to the -1. Now I'm ready to derive it. So I'm going to derive that, dy over dx. And if I derive it, it gives me -4x to the -2. And they're telling me that the gradient of the tangent, so the gradient of the tangent is -1. So what are we going to do? We're going to take this -4x to the -2 and put it equal to -1. And now we've got to solve. For me to solve this, I'm going to quickly do it. I'm going to take that x squared to the numerator, or the denominator, I mean. And now I'm going to step by step solve this. So I'm going to times out by that x squared. On the left, I'm left with -4. On the right, I'm left with -x squared. Which means, if I solve this, I've got x squared equal to 4. Remember, it is an x squared. Which means I am going to have two possibilities. So, my two possibilities are going to be x squared, let me just rewrite that, take a root on both sides, but now it becomes plus -4, which gives me positive or -2. In other words, there are two places where this graph has a gradient of -1. Now, I'm not done yet because they're asking me for points. So in other words, x and y. So let's substitute these x values in. So y equal to 4 over +2, which gives me 2. Or y equal to 4 over -2, which is -2. So just to finish off my sum, I've got 2, 2, and -2, -2. Ta-da! So now have I answered the question? The question was, determine the points. I gave the examiner the points, so yes, I've answered the question. Fantastic. Let's move on to the next question. You will see that I'm moving quite fast tonight. And I apologize if I'm going too fast for someone. Please remember, you can always pause, go back later on as well, rewatch, and make sure that you get this right. Let's go over to the next question. Now, the next question, ladies and gents, talks about the graph of a cubic function with the equation fx equal to x cubed plus ax squared plus bx plus c is drawn. They give me f of 1 is equal to f of 4 equal to 0. Now, I just want to hit the pause button at this moment. Let's interpret. What does this mean? Now, even if I didn't have a sketch, it's important for me to understand that y is 0, which means this would be the x-intercepts of the graph. That is very important, okay? Further along, it says that f has a local maximum at b, fantastic, and a local minimum at x equal to 4. Now, that is a bit of an important information for us because of where we are going. So the first question that they're asking me in 6.2.1 is show that a is equal to negative b, or negative 9 I mean, b is equal to 24, and c is equal to negative 16. In other words, they're asking me for the equation of the graph. With cubic graphs, I've always got two ways that I'm going to do that. One of two ways. It's either they're going to give me x-intercepts, or they're going to give me turning points, or they might, in very, very seldom situations, give me kind of a combination where I've got to solve simultaneously. Now, because they give me the x-intercept, let me just first, before I actually get to the equation, just write down what was given. X cubed plus ax squared plus bx plus c. So if I've got the x-intercept, I kind of know that I'm going towards this. X minus x1, x minus x2, x minus x3. The beautiful thing about this, and this is where this is a catch-out question. I actually asked that to my grade 12 group as well this year, and they were stumped because it feels like there's not enough information. But a very important thing is, whatever value is in front of the x cubed is the a value of the formula. So in other words, because there is a 1 in front of the x cubed, it means actually I'm sitting with 1 times by x minus x1, x minus x2. But now I'm going to do a nice little trick. This point here, where x is equal to 4, is not just an x-intercept, but it's also a turning point. So in other words, it's two things. So I'm going to write that in my formula twice. And I'm simply going to put in the 1, which is the other x-intercept. I'm just going to substitute it. So what I now need to do simply is, well, multiply out the brackets. So let's quickly do that. X minus 1, I'm going to take it kind of step by step. X minus 4, x minus 4. Do not forget to write out your brackets twice. Otherwise, you might just hit that middle value, that with the coefficient of x, and forget about it. So I'm going to multiply this out. If I multiply those out, I get x squared minus 8x plus 16. Then I'm going to multiply the x into the back bracket. And I'm going to do the same with a negative 1. Now, please excuse me if I do this in my head, just for the sake of time. If I look at this one, x times by x squared is x to the 3. X times by negative 8x is negative 8x squared. But if I minus another x squared, I get negative 9x squared. Going to do the same with the x's. X times by 16 is 16x. Minus 1 times by minus 8 is plus 8x. So that together gives me 24x. Now last but not least, I've got minus 1 times by this plus 16, which gives me negative 16. Now if you look carefully, a was what was in front of the x squared. So that means it's negative 9. B in the formula was what was in front of x, 24. And C is the constant, which is negative 16. Oh my goodness! I've proven what they wanted me to prove. Now here comes a very important thing. And I'm just going away. I'll get back to that screen now. Ladies and gents, remember, even if you couldn't do 6.2.1 and you got stuck somewhere, do not get stuck for like 15 minutes in an exam. Try it. It's maybe a 4-mark, 5-mark question. And then go over to 6.2.2 and tell the examiner, assume A is negative 9, B is 24, and C is 16. Because then you can at least do 6.2.2, 6.2.3, 6.2.4. Please remember that. It's a very valuable technique if you get stuck. And that's why we kind of give you prove that A is this, B is that, C is that. Stay with me, because I'm going to go over to the next bit of this question. So now that I've got an equation for f of x, the second question is kind of straightforward. Calculate the coordinates of B. Now, excuse me if I go over to a new screen. Y is equal to x cubed minus 9x squared plus 24x minus 16. If I derive that to dy over dx, or because it is actually fx, I should actually not write dy over dx, I must write f accent x. Because remember, that is actually f of x. So f accent of x is equal to 3x squared minus 18x plus 24. Okay, for those of you that may be struggling a bit with the quick derivatives, remember, we're bringing the 3 to the front, and I'm subtracting 1. Now, I just want to quickly just stop here for a moment and share this with you. Remember that the moment we derive, our notation changes from fx to f accent x, from y to dy over dx. Please remember that, because if you don't write f accent x, what are you telling the examiner that you actually do? You're just saying fx. But please show the examiner the moment you derive. Notation, notation, notation. Let's get back to the sum. They tell me that it is a local maximum. Now, a local maximum, I must remember, is when the derivative is equal to 0. So if I make the derivative equal to 0, so 3x squared minus 18x plus 24 equal to 0, now I need to solve this. So x squared minus 6x plus 8 equal to 0. Please remember, if you have one of those super fancy 991ZA plus calculators, remember, you still have to either show factorization or your substitution, especially if you're writing GDE final exam. But even IEB, I encourage you to still show your factorization or subbing into the quadratic formula. If I factorize this, x minus 4, x minus 2 equal to 0, x is equal to 4, or x is equal to 2. Now, 4 is not really applicable. You might ask me why. Well, on the sketch, 4 is not where B is. 4 is that one there. So, for me to not waste time, I'm simply going to substitute the 2 into the formula, and I've worked it out previously, and the answer that I got was 4. In other words, 2, 4. Just a little important thing. Remember to check your answers. Remember to make sure that it makes sense on the sketch. Let's say you got -4. That would not make sense because B is on the positive y. So y has to be a positive answer. Y is equal to 4, and that is fantastic. Let's quickly go on to the next question. So the next question is, determine the values of k for which fx equal to k has negative roots only. Now what I do in a case like this, I'm just first of all going to put in the information that I received earlier. Okay, there we go, I've got B. What I like to do in a case like this, there are two schools of thought. Either you can look about movement up or down, but that for me is really complicated. What I like to do, personally speaking, when they ask me f of x equal to k, I want to look at this as two separate functions. In other words, a cubic function, fx, as well as then y equal to k. Now, y equal to k is a straight line, a horizontal straight line. In other words, it will look, let me just get this a nice little spacing, there we go, something like that. Something like that. Now, if they're telling me f of x equal to k, it means where the two graphs are intersecting each other. So in other words, if they're asking me where the intersection has got negative roots, it means that they intersect where the x values are negative. Now, where do they intersect where the x values are negative? Well, I can see down here. This, they intersect on the positive side. I don't want that. They intersect twice on the positive x's. Remember, if they're talking about roots, they're talking about solutions. They're talking about how does the x values, the x solutions look for the equation. So for which values of k, remember y equal to k is this straight line, will it have negative roots? Well, that's everywhere underneath the y-intercept. Now, if I go back to my equation, the y-intercept is at negative 16. If you don't know where I get that, don't worry. It comes from the c value, the constant. So in other words, for k being anything under negative 16, that horizontal line that I've drawn will cut the graph only once, but it will cut the graph on the negative side. That's what I'm looking for. So in other words, I'm going to write that down. K smaller than negative 16. I hope you guys get that. I want to kind of just quickly diverge from this. What if they told you f of x equal to k, and they're looking for 3 possible roots? In other words, for which values of k, if I look at the cut between the horizontal line and fx, will it cut the graph 3 times. Now, in this case, excuse me if I'm going to quickly erase what I've gotten here on my sketch. Let me quickly erase and just go back to what I want to see. Just going to clean it up. That's a 2, 4. So if I look at this, here the graph cuts once. I don't want that. There the graph cuts once. Don't want that. Oh wait, there the graph cuts 3 times. They intersect 3 times. So that's what I'm looking for. But the thing is, I can only do that up to that point of B, because there it would cut the graph twice if I extend the graph there. But also, it would cut twice if I draw exactly on the other turning point. So in other words, for the 2 graphs to intersect 3 times, the desired K value has to lie somewhere in that green colored in region, which is between 0 and 4. Then my answer would be for K between 0 and 4. Now, I don't want to include 0 or 4, because remember, if K is 0, there are 2 intersections. If K is 4, then there will be also 2 intersections. I want 3 intersections. Now, you can play around with this, and there are many of these kind of questions, and we can ask it in weird ways. Where does the graph intersect on the positive side? Or twice? I encourage you, go and practice. And remember, if you get stuck somewhere, you are always welcome to come and ask. Okay. For our last little question, 6.2.4, they're asking me for which values of x is the graph concave up. Now, I know, out of experience, you guys just want to derive, because you see concavity and you think about derivatives. So let's do that. I'm going to answer this question in 2 ways. Let's start by doing it the way that I expect you guys to do it. F double accent x concave up. So in other words, f double accent x bigger than 0. Second derivative, because we're working with concavity. So the second order derivative of fx is going to give me 6x minus 18, and if that must be larger than 0. Remember, we had f accent x, which was equal to 3x squared minus 18x plus 24. Remember that from the previous questions. If I now solve for x, I've got 6x larger than 18, which means x larger than 3. Easy. As my boys, they like to say, easy claps. This is a very simple sum. But what I would like to share is maybe a different way of looking at the concavity. Let's look at the graph. So I'm again going to clear up my graph quickly. A nice, beautiful little trick that you can always remember is that the point of inflection, where the concavity goes from concave down to concave up, is always, with cubic graphs, exactly in between the 2 turning points, which is at x equal to 3. So at x equal to 3, my graph goes from concave down to concave up. So in other words, oh, wait, that's exactly what we wrote down. Easy, easy as pie. But I want to share this, and I want you guys to always think of doing a sum in more than one way. For those of you learners who are aiming for your 80s and your 90s, I encourage you, always try and find 2, 3 different ways of doing a math sum. I remember one of my friends telling me the difference between a medical doctor who gets 60% and a medical doctor gets 80% is someone that can give 5 diagnoses for a set of symptoms instead of just 3. So I encourage you, find more than one way of doing it because you don't know what the examiner is going to do. So let's carry on to the next question. Now this next question was sent, the next 2 questions actually was sent in by Tshepang Mboweni, very famous surname in South African circles at the moment, definitely. So what I'm going to do is I want to share with you, and let's attempt this. This now is where life becomes a bit more interesting. And some of you might be very familiar with these kind of questions, where we give you the function of f accent x as a whole new graph. So in other words, f accent x is equal to y. Let me just write that over. F accent x is equal to y. Now this is one of my favorite type of questions because it tends to lend itself to some beautiful interpretations. So what I'm going to do is I am going to answer the question, but I'm also going to diverge and see, but what does f accent x tell me about the original fx, but also about the second order derivative? So buckle up, we're going to have fun in this question. So when I look at this question, they tell me that the graph of y equal f accent x is represented, where fx is equal to ax cubed plus bx squared plus cx, and that represents a cubic function. Determine the equation of f accent x and the cubic function, the parabola. Now, or let me rather just quickly stop and say, for those of you that are doing AP maths, resist the temptation of doing this by integration, because we are not required to do integration, and you don't know who's going to mark your exam end of the year. So please do not integrate at any cost. So what we are going to do is have fun. I'm going to try this by looking at fx and f accent x. Now, the beautiful thing is, if I kind of ignore that this is actually a derivative of a function, and I see this as being a function on its own completely, and I ask you to determine the equation of a parabola, I can almost guarantee you'd be able to do it. Because I've got the 2 x-intercepts. So in other words, I know that I'm going to go towards, again, x minus x1, x minus x2, with that beautiful a in the front. So let's substitute x1 and x2 into it. So x minus negative 1, x minus 5. So in other words, what do we have? X plus 1, x minus 5. A nice little trick that I love to use with functions and graphs is, can I read off or deduce the value of a from the graph? The answer is simply no, I can't do that. So what I have to do is substitute a coordinate in. Well, they give me 0, positive 15 lies on the graph. So y becomes 15. And let me just move this graph, let me just move this down a little bit so I don't jumble it all up. So then x is 0 plus 1, 0 minus 5. If I look at 15 is equal to negative 5a. a is equal to -3. Boom. I've got one piece of the puzzle. Now please hit the pause button. Does this actually work with the graph? If I look at that specific parabola, it has to have a -a value simply because the graph is frowning, as we like to say. It's concave down. So I know that I've got a good indication I'm on the right track. If you've got a to be 3, be careful, because then you just know you made a mistake. A has to be a negative answer. So let's finish off this one. I'm just going to go over to the side here. I have y equal to 3, x plus 1, x minus 5. So this gives me 3, x squared minus 4x minus 5. So y is equal to 3x squared, sorry, that's -3. I'm so glad I picked up on that. Plus 12x plus 15. Okay. Now comes the fun. How does this relate back to fx? Again, if you are AP Maths, resist the temptation to go and integrate. So what I'm going to do is I'm going to take the original graph fx and I'm going to derive it. So I'm going to go f accent x. Well, that is negative, or sorry, not negative. That is 3ax squared plus 2bx plus c. Now that is simply taking the function with the a's and the b's and the c's and deriving it. So what I'm going to do at this case is I'm actually going to compare the coefficients. So in other words, because they are the coefficient of x squared, it means they've got to be the same. So in other words, 3a has to be -3. So a is -1. Next up, if I compare the next one, which is the 12, it must be equal to the 2b. So b is 6. And the last one is the easiest of them all. C must be 15. And there, gentlemen, you've got A, B, and C. In other words, you have all that you need. But this is now important. Have we actually finished off the sum? And the answer is no, because they asked me for the equation. So lastly, I would write, therefore, f of x is equal to, a is -1, so -x cubed, plus 6x squared, plus 15x. Have I now answered the question? Yes, I have. And therefore, I can go on to the next question. I can go over to where I want to go next. Was this tricky? Yes, it was. I'm not going to lie to you. If you don't see that you can constantly relate fx and f accent x to each other, then it is going to be quite tricky. Let's be honest. So what I want to do now is, Tepang, I'm going to actually just take this question, I am going to modify it a little bit, and I am going to have a look at, taking this question and looking at how would fx look even without having a, b, and c. So quickly, just hold on. I'm going to copy and paste this lovely picture. I'm going to copy this. and I am going to put it on a new one. There we go. Done. How would fx and f accent x look? Well, what I like to do is, first of all, before I actually answer how fx and f accent x looks, I like to interpret what I've got. First of all, I've got these 2 points or coordinates where y is equal to 0. In other words, okay, let's actually forget about the in other words for now. Let's just interpret. In between here, between -1 and 5, my y value is positive. On the left of -1 and on the right of 5, my y value is smaller than 0. Okay? I have not done any interpretation or big interpretation, but what I'm going to do now is just remember y is f accent x. So in other words, f accent x must be bigger than 0 at the green ones, which means f is increasing, f is going up. On the red one, I'm telling you f accent x is 0, which means that is a stationary point. So fx has got 2 stationary points at x equal to -1 and x equal to 5. And if I look at the blue part, remember y is f accent x. That means that f is decreasing on the right hand side of 5 and the left hand side of -1. So let's quickly get a move on here, and let's draw fx. I'm going to try and do it on approximately the same scale as there. So there's 1 or -1, there's 5. So I know that at -1, my graph turns or is stationary. At 5 as well, my graph is stationary. Between -1 and 5, my graph is increasing. On the left-hand side of -1, my graph is decreasing. And on the right-hand side of 5, my graph is decreasing. In other words, this graph has to look something like that. Okay, let me rather make sure that I've got my turning points right. Here we go. So there's my one stationary point, there's my other one. And that is a rough sketch of y equal to fx. Very important for you to understand this. Very important for you to be able to draw this. Now, the only reason why I drew that it goes through 0, 0 is simply because they told me fx, the value, the constant at the back is +0. It doesn't always have to go through the origin. It could have gone like that if the C value or the D value at the back was smaller than 0. Or if they didn't tell you and they just said a rough sketch. It doesn't matter what the C value is, or I'm thinking about C values for parabolas the whole time. The constant value at the back, if that is not given, then you just draw a rough sketch. Where do we give marks? We give marks for the form of the graph. We give marks for the stationary points, the position, in other words, the x values. We give values for that it's a cubic graph, but also important where it increases and where it decreases. Usually this is about 4 marks. 2 marks for the turning points, 1 mark for the shape of the graph that's cubic, and also 1 mark for this starting from the left up, going down, up and down again. So decreasing and increasing. Now, interesting, what we also need to do is how would if double accent x look? Let's quickly look. I'm going to go over to a new slide and look at if double accent x. If I look at this graph, remember that y is equal to, let me do it in black. Y is equal to f accent x. So to get to f double accent x, I need to derive this function. So I need to go dy over dx. In other words, the rate of change of the sketched graph. Now, if I look at the rate of change, in other words, increasing or decreasing of this graph drawn, the graph increases there up to a point, and then it decreases from that point on. Now that little point there is the point of, I just like to call it the point of inflection. For those of you, for the Afrikaner oaks that are boys and girls that are looking, die punt van infleksie. Dit is natuurlijk waar hy van konkaaf na onder na konkaaf na bo toe gaan. I'm going to switch back to English. So where the graph goes from concave up to concave down. So when I look at this, again, my point of inflection is going to be exactly in between my two x-intercepts. So it is equal to 2. So, what does this mean? At x equal to 2, the second order derivative is equal to 0 because it is the derivative of that y value. Remember, to get a turning point, you have to derive. So if I derive y once, put it equal to 0, it's the turning point. If I relate that to f double accent x, that will be where f double accent x is equal to 0. Now here, dy over dx at the blue line is smaller than 0. The graph is going down. In other words, I don't want to spend too much time on this, but the second order derivative is smaller than 0, so my graph is going down. But on the red one, if dy over dx is bigger than 0. In other words, if double accent x is bigger than 0, which means my graph looks like that. And there, ladies and gents, you've got the second order derivative. I'm going to quickly move on to an optimization type question, which I found very, very interesting. Again, thank you, Tepang, for sending in this one as well. You sent in quite a few amazing questions. So what I'm going to do is I'm going to handle one of the ones you sent in. And I'm going to check the rest of this week. And I'm going to do on the next video, I'm going to do one of the other ones you sent in to me because they are beautiful. So I'm going to attempt this next one with you all. Buckle up, it's going to be fun. The sketch shows a rectangular box whose base ABCD has AB to be 2x and the side to be x. That one I'm going to affectionately just name h for the height. Now I'm going to look at starting to bisect or dissect this scenario by looking at the information. The volume of the box, boom, there's my big clue. Volume is 24 cubic meters. I'm going to put a pin in that one. Then they all of a sudden go over to the material to cover. Now that's a very important distinction you need to make with optimization. Volume or capacity, not exactly the same thing, but we kind of interchange the two things at school level. Volume, you've got your set of formulas. But material is always total surface area. So material to cover, material to make, to manufacture is always the total surface area. Now all of a sudden they bring in something else. Cost. Oh my goodness. They bring in cost both for the top and the rest of the thing. Man, this is a lot of information. So what I'm going to do is, let's start at question 14.8.1a. Show that the height, there's my monkey, the height of the box. So I know that my height has to be a certain formula. So what am I going to do? I'm going to start by looking at our want height. But they gave me volume. There's my mountain. But for me to find the other mountains, I need to bring in a formula. I'm going to bring in length times breadth times height because it is a box. Remember, your prism formulas will not be given to you in the final exams. Pyramids, spheres, cones, they will give you, I've got a good suspicion they'll give you, but I would just go and study them because it makes me feel super smart. And it's a nice party trick to have to know all the formulas. Boys, you can chat up that girl at any party if you drop that the volume of a sphere is 4/3 pi r cubed. Maybe, maybe not. But let's try in any case to get the volume. Let's substitute in what they gave us. They gave us the volume to be 24. The length of the box I'm going to choose to be 2x. The breadth is x. And the height I do not know, but I want height as my subject. So I'm going to divide both sides by 2x times x, or just 2x squared. So in other words, 2 goes into 24, 12 times. X times x is x squared. That is height. Now just look at the answer they give you. Wait, let's just manipulate 12x to the negative 2. Boom! It's done. So let's look now. Remember, and I'm going to stress this. Remember that if you couldn't even prove the A part, do not give up hope. You can still do the B part and the rest by simply using the A formula. Now question B, I suspect the author of this book maybe did not think through, because 3 marks is very little for this. In the exam, I suspect this should maybe be 4 or 5 marks. I'm not criticizing whoever wrote this book, but I'm thinking it's a bit more work than 3 marks. So the B part asks the total cost. So now they are asking me to find at the B part cost. But for me to get cost, I need the total surface area of the shape. But here is a bit of an issue now, because the surface area is priced at different ranges. I'm going to split up the surface area in the top part and the rest. The top part area, if I draw it the top of the, and they told me the top is PQRS, is 2x times pi x, because that's the dimensions, 2x times x. So the top part is 2, that's a bit close, 2x squared. If I look at the rest of the shape, and I like to fold open my shapes. It's just one of those things I like to do. So I've got a bottom, I've got a back part. I have a bottom part. And I have a left hand. And I've got a right hand. Okay, I'm just going to actually quickly try and move this one. So I've got a bit more space. I just love to do this. Let me make it bigger, because bigger is better, especially with these kind of sums. But then I also have, now maybe that was a bit too big. Okay, let's try that one again. Okay. There we go. I also have a front part here. Now, to get the dimensions, remember there's height and height and height, and all of these are x's, and all of those are 2x's. That's if I fold this thing open. So if I look at the surface area for this, for the rest, okay, it's a bit of a doozy, okay? But it's not that difficult. Let's quickly do it here on the side. The area, I've got 2x times pi x plus, then I also have 2x times pi height. Let me make my times rather a dot. Plus, I have 2x times height. And that kind of is now the formula for the area of the rest. Whoa, this is getting messy, guys. This is getting messy, and I apologize for that. So in this green little block, I'm going to look at cost. If I look at the cost of this, the cost, they tell me, is 25, okay, is 25 Rand for the top, 25 Rand for the top, plus 20 Rand times by the rest. Now, this, I think you guys are starting to understand why I said that this is a bit more than three marks worth. So for me to do the sum proper, I'm just going to go over to the next slide just so I have a bit more space. Okay, the wrong slide. There we go. So just what we said here, the cost, 25, the top is 2x squared, plus 20 times by the rest. The rest, there's a 2x squared. If you look at that, the rest, there's a 2x squared, plus 4xh, plus 2xh. But now, I don't want h in there anymore. So I'm going to substitute h with what we got. I'm going to substitute h by what we got in the previous sum. So 4x times by 12x to the negative 2 plus 2x 12x to the negative 2. Remember that we got from a. So this leaves me with 50x squared plus 20 times by 2x squared plus 48x to the negative 1 plus 24x to the negative 1. And if I now do my sums correctly, 50x squared plus 40x squared is 90x squared. Oh man, there I go, I've got it. I've got the 90x squared. Plus, now 20 times by 72, if I combine those two, is 1440x to the negative 1. Oh my goodness, we've got this right. I'm so chuffed. I just have to say this. After all that information, to get this right, this feels amazing. Let's quickly go over because our time is running out. Now, next up, they ask you the dimensions to make the cost a minimum. So to make the cost a minimum, I am going to derive and make equal to 0. So if I derive this and make it equal to 0, I've got 180x minus 1440x to the negative 2. Now I need to solve this. So to solve it quickly, 1440 over x squared equal to 0. If I multiply by x squared straight through, I get 180x to the 3 equal to 1440. X to the 3 is equal to 2. No, sorry, 8. So therefore, x is equal to 2. I've got my answer. Now I've got x. I'm not done because they ask me for the dimensions. So the length is 2 times 2. So that's 4. The breadth is 2. That's just x. The height is 12 over 2 squared. So that is 3. And there I've got the dimensions. Now, just for the sake of time, I'm not going to do I'm not going to do B completely. If I look at 14.8.2b, they ask me for the cost. And all I do for the cost is substitute x with 2. So 90 times by 2 squared plus 1440 times 2 to the negative 1. You put that in your calculator and the answer you get is, if my calculator was correct, 1,080 Rand. Whoa, this was a beautiful sum. This was amazing. I just want to say, it was amazing spending this hour and a bit with you all. It was so much fun doing this mathematics with you. Now, I want to just say, if there was anything that's unclear, or if I made a mistake, please forgive me. I'm so glad you all stick with me after that initial hiccup with the sound. Thank you all for listening to me, and I hope that I could help you a little bit in your journey towards mastering mathematics. This whole course is proudly sponsored by Junior Tux. And the guys from Investec are supporting us fantastic. But please remember to subscribe. Remember to hit that bell to get the notifications of what's coming next. In the course of this next month and a half, bit more of a month, so month and maybe 1 or 2 weeks, we are going to every 2 weeks release new maths as well as science videos, more notes, more worksheets. So please go and every week or so, just again go and click on the program to see if there were new videos uploaded, new worksheets with memos. It has been an amazing hour and a bit with you all. Have a wonderful evening. Stay warm, stay safe. This is Mr. VG signing out. Dankie vir die Afrikaanse oukies daarvan John Foster wat ek gehoor het wat kom intune het by ons. The rest of South Africa, you guys as well. It's been a fantastic hour. Have a wonderful, blessed evening. Cheers.